let's write a program now. Yeah, program to understand the various storage classes. Okay, program to understand the various storage classes and also the implementation of functions in stack based environment. Okay, right. Now let us take a global variable, say float f equals 3.14. okay, this is a global variable. Okay, then let's have a main function. Okay, I want you to pay attention. Okay, consider the line numbers of the line numbers itself as the addresses of the statements. Okay, now when this program is taken by the operating system and it is stored in process control block PCB, we know that it will have, every instruction will have its own address. Okay, so you have to know about it. Okay, so now here what we will do, in main now. Okay, then what we'll do, we will call say Shri Sailam is a place, right? So assume it is a function I'm writing. Then what I'll do, printf I am back in main now. Now what I'll do, for time being, I'll simply take int I equals 10. Okay, right? Local variable of main function. Okay, right? And what is this? Variable. Okay, right? Just visible to all functions in the program. Okay, right? Now what I'll do, pay attention, I will declare, say void, we'll define one more function, void say nellore. Okay, okay, we'll say put s, we came to enjoy the beach. Okay, right? Okay, so then all say okay, then we'll say we came back again to learn from Sri Hari Kota. Okay, right? So here in this function what I'll do is static some variable. Okay, d equals 3.007, some number. Okay, all right. Okay, it is mentioned as static. Okay, please note where I have not mentioned anything here, the storage class, but it will be auto. Okay, auto is nothing but automatic, that is by default. By default all local variables are automatic variables. Okay, right? Okay, so you have to note here, let's make a note, by default all local variables are automatic variables. Okay, what do you mean by local? A local variable is one that is defined inside a function or inside a block in a function or inside another block. Okay, right? So what is a block? Very simple. Pay attention. See, I can create a block here. Okay, right? And I can declare one more variable here. Okay, this is called as block. Okay, okay, okay. So now this is of not so significance. Okay, right? Why do we need blocks? We need block to put a separate set of statements and probably to declare variables which will have the life only inside that block. Okay, all right. Now let's continue. Yeah. So here what we'll do, we will call void, will again define a function void Vishakhapattanam. Okay, right? Okay, so here what I'll do, just register char ch equals a some table. Okay. Okay, a local variable which gets the memory in GPR, general purpose registers of the processor. Okay, what is this? A local. Why I'm saying all are local variables? Because they are all these variables, that is I, D and ch, they are all defined inside functions, inside the functions. So they are all local variables. Okay, go through the code. Yeah, please go through the code. What we have done here. Okay, we have to define Shri Sailam still. Okay, before that, what is? I'm sorry, I'm very sorry. Yeah, so here what we'll do is put as we'll write a printf statement. Yes, we came to visit okay Simhachal, something, right? Okay, so now it is the last is Shri Sailam. Okay, right? Okay, so now what we'll do here, you say came to visit the okay, so this is what we'll do, right? And then here we have to call Nello, right? And we will write one more came back again to enjoy the cruise. Okay, right. So this is the program. Okay, now let's begin from the main function. Okay, so here it will print what I am in main now, and it will call Sri Sailam, and we will say here we came to visit the Jyotirlingam. Okay, and then it will call Nellore. So now it will come to Nellore. It will say we came to enjoy the beach, and then it will call Vishakhapatnam. So here it will say we came to visit Vishakhapatnam, and then it will, now there is no more call from the Vishakhapatnam. So now the control has to go back. So where it will go back? It will go back to Nellore. From Nellore, where it will go back? It will go back to Sri Salam. From there, it will go back to main function. Okay. Now before I continue with this program, so now I want you to write down this. Okay. See, every C++ program, say what is this block is, assume this entire white area is say say RAM. In that, this yellow area is allocated to our program. What? The memory is allocated our program. So after the memory is allocated, what happens? The C compiler, okay, right? What it does is it will bifurcate this into 4 parts. Okay, I want you to observe this. Okay, so like this, 4 parts. Okay, what are these 4 parts? I'll tell you. Okay, the first part is called as code area. Okay, the second part is called as ADS. Okay, it is called as ADS. Okay, what is ADS? ADS stands for alterable data segment. I'll explain this to you one by one. Okay, and this is stack area, and this is heap area. Okay, right? Okay, let's learn one by one. What is this? Okay, first is code area. The code of the program is stored in this area. Very simple. The code that we write, so I mean to say for this particular program, the code that we have written here, including the comments, so everything will be stored here in this area, that is code area. Okay, right? I hope you are trying to understand. Now ADS, what is ADS? Alterable data segment. Now in the alterable data segment, what is stored? All the global and static local variables are stored in this area. It is the variables whose life has to be retained until end of the program. Okay, right? Stack area. Now in stack area, what we have, all the frames of the functions are stored in this area. Okay, then heap area, it is also called as free store. The dynamic The dynamic mean to say DMA, dynamic memory allocation happens in this area. Okay, that is runtime memory allocation. Okay, right? Okay, so this is what you must know. Okay, okay. Now inside every frame we have the auto local variables and the details like return address and linkages stored. So inside the frame, what are the data we have? The automatic local variables are stored inside the stack inside the frame, as I have shown you yesterday with the swap program. Okay, and also other than that, the address I have shown you yesterday, and also the also something called as linkages will be stored. What are these linkages? The linkages will be used to link between two functions. Okay, because when one function has to call the other function. Okay, so where it is stored in the code area, we have to know. Okay, so these linkages are stored during the linking stage of a program. Okay, the different stages of a program also I will show you. Okay, fine. So I hope you have understood this. Okay, what is this yellow area? It is the area that is allocated by the OS to our program. Okay, right? I hope you are understanding. Okay, and for each of this area, okay, I've given you the explanation. Okay, out here. I hope I am audible to you people. Okay. Okay, fine. Thank you very much. Now let's continue. I hope you people are listening to the class, and I'm sure this is very interesting. Okay, right? So I hope you have learned this. So let me save this. Memory mapping of a program, and please note this is same for C and also C++. Okay, this is same for both C and C++. Okay, now next now let's come back to this program. Okay, now what I want you to understand is, please note for this program, now we will trace. Okay, as soon as the program runs, there is a frame created for main. Okay, so this frame is for main. Okay, now where this frame will be, it will be in the frame will be, it will be in the stack area. Okay, it will be in the stack area. Okay, now next, before the program start running, I mean main start running, the float f, okay, the float f, which is a global variable, it will get memory allocation here in, I'm sorry, it will get memory allocation here in ADS. Okay, what is ADS? Read it. The variables whose life has to be retained till end of the program are stored here. I hope you are able to understand. Okay, so f 3.14 is okay here. Okay, yeah. So now let us okay, now let's save this, and again I will say save as. what I'll do is, just a moment, I'll save this. Yeah, okay. So now let's continue here. Okay, so what we have here, we have f equals 3.14. Okay, when this is stored, even before the main frame is created, even before the frame for the main function is created, okay, this is stored in the ADS. Okay, global variables have the life more than any other, more than any function in the program. Okay, so now let's I'll remove this for time being. Okay, okay, fine. Yeah, all right. Okay, so now next the main starts running. Okay, in the main we have I equals 10. Okay, so come here. So what happens, this I equals 10. Okay, right, this I and its value is 10, right? So I, okay, and its value is 10 is stored inside the block like this. Okay, right? Okay, and where this frame is available, where this frame is stored, inside the stack area, inside the stack area. I hope you are trying to understand this program. Okay, right? So now you have understood this. Okay, see, all the frames of the functions are stored in this area. Okay, right? So the main is also stored in the stack area. Now what happens, let's go back to the program. Say 12, the statement 12. Okay, statement 12, that is I am in main now. When it is running, it will be pointed by IR, that is instruction register. Okay, right, and PC will be pointing to 13. Okay, right, okay, right, okay. So then now say suppose IR, okay, that is I am in main now, so it has run. Okay, it has run. Now next is 13 has to run. When 13 is running means what? The function call statement. The function call statement is running means what? The control should leave the main function and go to the called function. Okay, before that, what is now PC? PC is 14. Okay, right, 14. Okay, its address is 14. Okay, so that is stored inside the frame as return address. So RA is 14. Okay, so this is stored inside the frame. Now this is pushed onto the stack. So let's create one stack. Okay, right, let's create a stack. So we have created a stack. Now what we'll do, we have to push this onto the stack, correct? Okay, so now this frame is there inside the stack. Okay, who is pointing to it? Stack pointer is pointing to it. Okay, right, so SP, so stack pointer is pointing to it. Now next, what happens? A new frame is created for which function? A new frame is created for which function? For Shri Silam. So let's go to the Shri Silam function. In Shri Silam there are no labels at all. Okay, so that will be, so this will be empty, isn't it? Right, so this is, say, Shri Silam. Okay, so this frame is for the function Shri Silam. Now what we are doing there? Okay, let's IR is now 33. Okay, PC is 34. Came to visit, so this is printed. Okay, now IR is 34, PC is 35. Okay, now when IR, that instruction has to run, that is function call statement. What happens? RA, return address. RA, that is return address. What is the return address? 35. Okay, 35 is stored inside the frame. And now what happens? This frame is pushed onto the stack. Okay, I hope you are observing what I'm explaining. Okay, so this is pushed onto the stack. Okay, right. Next, what happens? Next is the stack pointer has to be incremented. Okay, the stack pointer is now pointing to the frame Shri Silem. Okay, right. I hope you are understanding. Okay, now next, again a frame is created. So again a frame is created, but this time to whom it is? This time it is for Nellore. So now come to Nellore. As soon as the control comes to Nellore, what happens? This function, this frame gets. Okay, now when a function is running and this say frame is being pointed, isn't it? So being pointed by whom? It is FP, frame pointer. Okay, FP, frame pointer. Go and study the registers that I explained you yesterday. That's very important. Okay, so now in Nellore, what we have in Nellore, we have double D. Okay, so there is, but it is mentioned as static. Okay, but it is mentioned as static. So what happens? It will get memory allocation here. Okay, so D equals 3.007. So it will get memory allocation here in the ADS. Okay, here in the ADS. That's very, very important. Okay, right. Please mention why it is getting the memory allocation there, because it is mentioned as static. Okay. 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 Now next is now let's continue. Let's continue. So now here, what happens? What happens? We came to enjoy the beach. Okay, so that is printed. Now it is calling Vishakhapatnam. So Vishakhapatnam, the function call statement is being pointed by IR. Okay, PC is 22. So first, before the function Vishakhapatnam is called, okay, this is RA. Okay, what it is? 22, isn't it? Right? So RA 22 return address. Okay, that is content of PC is stored, and now this is pushed onto the stack. Okay, right? So this is pushed onto the stack. Okay, now once it is pushed, okay, the FP is null, because FP is for time being, it is not pointing to any frame. Okay, so FP is null. Now SP has to be incremented, correct? So SP is now lastly the frame we have to create is for Vishakhapatnam, correct? So frame for Vishakhapatnam is created. Okay, right? Now what it prints? It prints we came to visit Simhachalan, and now observe there, this is very important, line number 26. Observe line number 29. Okay, observe line number 29. It is end of the function. It is end of the function. So what happens? Now you must know what happens. This frame of Vishakhapatnam is deleted. Okay, right? It is deleted. So let's delete it. So we have deleted the frame of Vishakhapatnam. Please note, now FP is null. FP, frame pointer, is null. Now, is it end of the program is what the compiler has to check. But before that, it will check if there is any stack. Yes, stack is there. So what we have to do? We have to pop. Okay, so this frame is now popped. FP is pointing to it. Now SP is decremented. Okay, SP is decremented. I hope you are now getting how the functions work in C, C++, Java, all this. Okay, now where it has to go? It has to go to the return address 22. So where is 22? Here. Okay, and now it will print. We came back to learn. Okay, now there is end of the function 23. Okay, so what happens? As you can easily guess, this frame is deleted. Okay, right? So deleted, gone. Okay, now the top frame is popped. Pop it. So now FP is pointing to it and SP is now decremented. Okay, so it is decremented. Okay, right? Now next, what happens? It will go to the return address 35. Okay, so it will go to the return address 35. Okay, right? Came back again to enjoy the cruise. It will print and then it is end of the function. So when it is end of the function, as we know, this is deleted, gone. Okay, now the last frame, that is of main, is popped. Okay, now there is no more frame, so the entire stack is deleted. Okay, right? The stack is deleted and SP, stack pointer, is now null. Now the control goes to return address 14. Okay, and it will say I am back in main now. Okay, right? Isn't it? Okay, right? So please note, once the function is over, where it should go back, it is stored in memory. See, if it is not stored in memory, how could it know where the control should go back? Isn't it? So now at the end, what happens? The main is also deleted. FP is null now. Okay, so I mean to say FP is also gone. At the last, these two variables are deleted. Okay, after deleting the frame of main, this is deleted. Okay, right? I hope you have enjoyed this program. Okay, so now I want you to once go through. I'll give you a time of a minute. Okay, so please try to discuss among yourself and understand the code. Okay, right? So this is the program. I'm giving you some 30 seconds of time. Okay, fine. So now let's continue. I hope you have tried to understand the code. Okay, okay. Now let's save this for your reference. I'm sorry. Okay, let's continue. Yes, so we are here. Okay, all right. Now the program will be to understand, program to understand the storage class, program to understand the storage class auto. Okay, okay, right. So automatics, local variables, how they behave, what are their uh, what are their characteristics is what we are learning. Okay, so now pay attention please. So now here what I'm doing, let's take some variable, say int var equals 50. Okay, right. Okay, so what is hidden here? Auto is hidden. So wait, what I'll do is int I equals, I'll call a function increment. Okay, now write the prototype of this function. What it is? Int, because it is returning one integer variable, integer value. Okay, so int I equals increment. Printf, what we'll do, I equals %d comma I. Okay, so we are printing the value of I. What we'll do next, we will copy paste this. Okay, we are doing the same thing again and again. Okay, right. How many times? Some 3-4 times you do it for your So now let's define the function increment. Okay, so what we will do here, int j equals 0. Please note j is also auto. This is very important. Okay, j is auto now, correct. I is also auto there in main. Okay, right, but we are very much concerned on the variable j. All right, so now what we'll do, j equals j plus 2, return the value of j. That's it. Okay, so what I'm doing, I'm incrementing the value of j by 2. So how can I do it? You can also say j plus equals 2. Okay, so here it is written j. Now come on, let's use the previous program and try to understand what happens first. What happens first? A frame is created for main. Okay, isn't it? Right? A frame is created for main. FP is pointing to it. The variable I will get memory allocation inside main itself. Okay, inside main, isn't it? Inside the frame of main, right? Because it is automatic local variable. Okay, okay, fine. So now we have to call we are at line number 9. We are calling the function increment. Please note PC is also 9 because that initialization has to happen. Okay, right. So PC and IR both are 9 here. Okay, right. Okay, so one is function call statement. Now PC is the assignment that has to happen, which is pending. Now what happens? The frame of main is pushed onto the stack. So now you have to imagine whatever we did for the last 2 programs. Okay, now come on. What happens? Now a frame is created for increment. Okay, please note inside the stack the frame of main is there and SP pointer is pointing to it. Okay, the stack pointer is pointing to it. Now next what happens? Here the J is created inside the frame, inside the frame of, say, how it will be. Now I want you to pay attention. So there is one there is a stack. Inside the stack we have the frame of main. Okay, and outside here we have the frame of increment. FP is pointing to this, SP is pointing to main. Okay, right? And then what happens? Now a J is created. Where it is created? J is created here inside the frame of increment. So this is J. its value is 0. Its value is 0. Okay, right? Pay attention, right? Now j value is incremented. So now the j value here inside is 2. It is 2. Now next, what happens? We are saying return j. So the value of j we are returning, that is 2. Now once the control returns, this frame is deleted. Please note, when the frame is deleted, the content inside the frame is also deleted. Now please understand, when we say that we lost our college bag, okay, so we need not have to say that the books, the wallet, the pen, etc., water bottle, all are lost, isn't it? Okay, we need not have to say separately that I also lost the books and water bottle, etc. uh, the bag is lost means the content of the bag is also lost. Okay, in the same way here the frame is deleted means the j is also deleted. Okay, all right, so the j is also deleted. So now what happens next? The frame of main is popped. So then what happens? The stack is empty, so stack is deleted. Okay, now what is the value of I? 2. So now here what is printed? 2. Now again I'm calling the function increment. So what happens? Again the main frame is pushed onto the stack. The main frame is pushed onto the stack, isn't it? Right. Okay. So this is of main, is pushed onto the stack. Okay. This is of increment. Okay. All right. Okay. Right. So now j again it gets memory allocation. Please note, now this time j is new. It is a new variable. Okay, its value is 0 now. Again what we are doing? We are incrementing the value of j here by 2. Okay, right? So we are incrementing. So what is the new value of j? 2. Return j. So what is written? 2. So what is the value of I? It is 2. So what happens? The frame of increment is deleted. So frame of main is popped. Okay, right? So here what is printed? 2. Okay, again I'm calling. So again the frame of main is pushed. Again one frame of new frame is created for the function increment. Okay, right? So please note, the code area, in the code area we have only one piece of the code. Okay, right? Only one copy of the increment function code, but this memory allocation, that is the frames that are allocated, is for every call. For every call a new frame is created. That is what you have to note. So again value of j is incremented to, and again the value of j is written, the increment frame is deleted, main frame is popped. So again I is now 2. Okay, so now it is 2. Okay, now run this. Okay, I'm sorry, so this should be I is already declared. You can declare one variable only once. See, I equals to, I equals to, I equals to. I hope you are trying to understand. Okay, okay. Now I want you to pay attention. Now I'm going to do some changes here. I'm going to remove this auto. I'm making it static. I'm making it static. So now what is the changes? Let's see. Let's see. Okay, I want you to pay attention. Now please note. Now please note, this j is, the j is no more there inside the stack of increment. It is here in, it is here in what? The ADS. Okay, right? For that the memory is allocated here in ADS. It is j. Okay, right? The memory is allocated here in. Okay, I hope you are trying to understand. So j is here. Okay, all right. Now let's continue. Now what happens? Let's see again. Just 1 minute. Yes, that is correct. You are exactly right. 2, 4, 6, and if you continue again, it will be 8, 10, and so on, right? Okay, so why it is happening like that? Let's see. Okay, so now main is created. Inside that there is a variable I. Okay, so inside that there is a variable I, right, which was already there. I had not written it, so I'm writing it now. Okay, so this is I. Okay, so now what is the value of I? Before that we can know the value of I. Increment has to be called. So once the increment is called, now j will get its memory location and its value is 0. Now I'm incrementing the value of j. So j is now 2. Okay, j now, okay, and I'm returning the value of j, that is 2. Now once control leaves increment, okay, the frame is deleted, but j is not deleted. Please note the j is not deleted because j is not at all there inside the frame. Okay, okay, right, and then the value of j here is 2. Again I'm calling the function increment. So again increment frame is created. Okay, but please note this time the j is not created again. This time the j is not created again. The reason is j is already there in eds. It is already there in eds. Okay, so it will continue with the statement. So what statement? This one. Okay, line number 24. Okay, so j equals j plus 2. So what was the earlier value of j? It was 2. So now it becomes 4. Okay, so now it becomes 4 here. Now again the frame of increment is repeated. The control comes back to main. So now j is 4 here. I'm sorry, I is 4. Again I'm calling. Again the frame for increment is created. Okay, j is not declared there again. Please note because it is already there in memory. Now j value will be incremented to 6 and a 6 is returned. Increment frame is deleted. Okay, main frame is popped. I value is 6. Okay, let's run this. See, okay, look at the output. Look at the output. I hope you have understood. So we have learned two storage classes, auto and static. Now let's learn register. Okay, now let's learn register. Okay, for time being we'll save this. Okay, all right. Okay, I want you to pay attention now. So here we are going to write a new program. Okay, int I equals say what we'll do, 0 or say 1. Now say suppose I want to run a loop. I have explained the register on in the probably second class or something. I hope you remember it. Okay, that is we calculated the time required to run the loop. Okay, so I equals 1. It is running for very big number of times, say 10 lakh times. Okay, so this is 10 lakh. Okay, I plus plus. So now we are doing something here inside the loop. Okay, right. Okay. So now here what is the time taken for this loop will be is what I have already explained. Okay, so I'm not going to explain it again for you. Please go through the second class number 2. If you want me to recall it, I'll recall it. Okay, so just yeah, this is the one. Say this loop is running for 10 lakh times and assume the time taken is say 40 microseconds. Okay, 40 microseconds for each fetch. For each fetch of I from the RAM, that is from the stack area of the RAM, Okay, right, from the stack area of the memory that is allocated to our program, which happens in the RAM. From there the I is fetched, okay, and stored in one of the general purpose register. Okay, so what is this I mentioned? Okay, so this is general purpose register, this is special purpose registers, I explained you. Okay, the time taken for each fetch of I, okay, right, to check the condition or to check the or to increment. So what it is 40 seconds. 40 microseconds is for one fetch. I'm sorry, so like that 10 lakh times we are fetching the value. Say 40 seconds will be the approximate time. If we really get the memory for the variable in general purpose register, then we can make it in only 6 seconds, because then the time taken to fetch directly will be only 6 microseconds, is what I had explained you that day. Okay, right. So I'm sorry. So the register is used to register storage class must be used on those variables like loop counters example, okay, which are accessed so many number of times in a small piece of code in a program. Okay, please note, you should not allocate the memory for array or structures in register, which is actually a foolishness, because the registers will not be of such a big size to store arrays or structures. Okay, and not even global variables must never be registered. Okay, because global variables, their life is very big, so keeping the register busy for such a long time is not good idea. So now let's wind it up by using a uh, by learning the entire storage class, by putting the entire storage class into one diagram. Okay, this diagram you will not find it anywhere, so please learn it from me, okay, thoroughly. Yeah, now we have 6 columns: storage class, then the keyword for that storage class. See, storage classes talks mainly 3 things: storage, where it is stored, the life, and the scope. Scope is nothing but your accessibility. And lastly, initial value. The initial value is of not so much important. It is not much of significance. The reason is the initial value depends on compiler to compiler. Okay, different compilers that we use. Now let's begin with the automatic local variables. What is a keyword? Auto. Storage within the frame of the function, isn't it? Right, within the frame of the function. Life, what will be the life of the automatic local variables? Within the function or the block. What is a block? I have shown you in the previous example. Okay, where it is accessible, where the variable is visible. Local variables, they are visible where they are declared, okay, inside the block or the function. It's very simple. Initial value usually junk, but recent compilers, they initialize the variables to zeros. Okay. Next, register local variable. Keyword is register. Where the storage is for the variables? In general purpose register of the processor. What is the life of a local variable? Very simple. Within the register local variable, within the function or the block. Where it is accessible, all local variables, they are accessible inside the same function or the block. Then the initial value of the general purpose registers are also junk. Okay, then static local variables. Okay, what is static local variable? The local variables whose life we want to retain till end of the program. Okay, so keyword you have to use is static. Storage in alterable data segment. The next, life is till end of the program. Okay, see, please note, it will not get the memory allocation at the beginning only when the control goes to that function where the static local variable is declared, only then it will get the life. Okay, right. If the function is not, then it will never get the life at all. You have to note it. Okay, then visibility is inside the function only. Okay, right? And lastly, the global variable. Global variable, there is no keyword, so I've left it empty. Okay, storage is again in the alterable data segment, as I have explained. Okay, life is life of the program, very important. Okay, even before the frame for main is created, the global variable will get its memory allocation. Then where it is accessible, anywhere in the program, in all the functions. Okay, initial value would be 0. I hope you have understood this. Okay, any doubt? Okay, there is no doubt asked. Okay, I hope you have enjoyed today's class. Tomorrow I'm going to start with pointers. Okay, for pointers I need 2 classes. Okay, and thereafter arrays and strings, again I will take 2 classes. Okay, so Monday, Tuesday it will be on pointers. Okay, Wednesday, Thursday it will be on arrays, and then string.